right, today we are going to do the quadratic formula. You don't know what that means. That's okay. I'm going to show you what it means in like one easy little lesson. So here's what happens is we have a lot of things in life, especially science, that are modeled by quadratics. So acceleration is like a quadratic. There's, I don't know, lots of things. But basically, if you think about a bouncing ball, it bounces up and it comes down, and it comes up, comes down, right? And then it makes these things, and these are actually mathematically represented by parabolas, right? Parabola is the shape, and then the function type is called a quadratic. I don't know why it's called quadratic because it's x squared, but it looks something like maybe like y, oops, I was dumb, equals 3x squared plus 7x minus 5. In this case, you might have like a negative 9.8 x squared, right? And then you could see like where it hits. See this equation, you can actually from the equation tell, okay, when is my y value 0? I guess it'd be like plus 10. If it was plus 10, x is 0, y is 10. Actually, this one would be here. I don't know, whatever. What happens is you have a graph and it's modeled by some weird function, y equals ax squared plus bx plus c. Okay, something in this form where a, b, and c are all numbers, fractions, decimals, whole numbers, doesn't matter. But usually what happens is when you have a function like this, it's going to be maybe up here, maybe it's going to be on this line, maybe it's going to be upside down. You don't know where it is, right? And the one thing that's really helpful is to know where it crosses this axis, the x-axis, right? Like this is called the zeros of the function, right? So you might really want to know that. You might want to know like maybe it never crosses the zeros, right? Maybe it never crosses. Maybe you want to know that. Maybe it hits once, like maybe your vertex is right here. It just hits one time. So it's really helpful for us to know when it hits the zeros, and you got to talk to a scientist to know why. Okay. So what we do is we say, well, if it hits 0, what happens? Well, that means the height is 0, and so that means y is 0. So I'm going to say, well, what happens when y is 0? And ideally, what I want is to figure out what x is. In an equation, a normal equation, you would have something like this. Minus 3x plus 7. These numbers, the a, b, and c are just numbers, right? X is your independent variable. So if we can find what x is, if we can get x equals something, we can plug in those numbers in our calculator and we know x, right? The problem is that's a pain. It's a pain to do unless x is by itself. And it's a pain to do over and over and over again. So I'm gonna do one for you just to show you how painful it is. Let's see. I'm gonna make it some terrible number. I don't even know if it's gonna work. So we'll just say 4x squared plus 10x plus 7. Okay. And we say, all right, well, how could I possibly figure out? Let's like straighten this up a little bit. What x would be? I have to get x by itself. So you're like, ugh. Let's see. Well, let's just take away 7 from both sides. Okay, so we get negative 7 equals 4x squared plus 10x. And then I'm like, well, I could factor out a 2. Okay. Okay, I still have some x's here. I can divide by 2 if I feel like. Let's see. Ugh. Well, let's divide by 2 again, just see what happens. So we get 7 over 4 equals x squared plus 5 over 2x, which still is like, how do I get x by itself? I can't factor out an x. So there's this cool method. Let's come over here and practice this method real quick, and then we'll bring it back. school method. And so if I have, let's do an example. If I have x squared plus 10x, right? If I have 25 here, if I have 25 here, then I know that this actually equals x plus 5 times x plus 5. So you've probably done this. So if you distribute this out or FOIL it or whatever you want to say, you would say x times x is x squared plus 5x plus 5x plus 25, right? And then you say x squared plus 10x plus 25. Okay, well that's, so you can see that this equals this, okay? So you're like, well, that's fine. You just made that one up, all right? Well, let's try with another one. If I want to do this one, I say, man, I sure wish I had and I wish what I had was a 16, because 16 is 4 times 4, right? Plus, and 2 4s add to 8. Okay, so I wish that was a 16, right? All right, well, what about like 6? Well, 6, I need half of 6 is 3. 3 squared is 9. So I sure wish this was a 9, because if this was a 9, then I could actually say x plus 3 times x plus 3. Now, what's great about this is I can rewrite this as x plus 3 squared. Then I could take the square root of it, and then I only have like 1x. I don't have x's here and here. Okay, that's kind of our goal here. So this is called completing the square. And we'll kind of have to go through like the process of what do you need to have for completed the square. So far I've just done even numbers. Well, what if I had 7x plus? What do I wish that would be? Well, I need two things that multiply to 7, which would just be 7 divided by 2, 3.5. So I would need, whatever this number is, I would need it to be 3.5 squared, or 7/2 squared. Then if I did 7x plus 3.5 times x plus 3.5, I don't even know what 3.5 squared is. Who cares? But I know that this times this is 3.5 squared. And I know this plus this is 7. Okay. So let's try it with a, just number. Let's try B. Okay. I wish this was whatever this is divided by 2. And then I'd have to square it. If I added this term divided by 2 and then squared it, then I could rewrite this term as x plus b over 2 times x plus b over 2. Then I could write this term as x plus b over 2 squared. Okay, so that's this process of completing the square. Now, granted, you can't just add stuff randomly to an equation. You can't, but you have two sides, so you can add to one side, and then as long as you add to one side and you add to the other side, then you're okay. So let's go back to where we were. All right, let's see. We had here, we got rid of this 7. We kind of took out this 2. We decided to take out the 4. So we ended up x squared plus 5/2 x. And man, it would be nice if we had something we could add to here, but we do. So let's see what that is. I'm going to take this term, just like the b, and I'm going to divide it by 2, and then I'm going to square it. So 5/2 divided by 2 is actually 5/4. So I would say 5/4, and then I would square it. Now, I can only do that if I add it over here. I have to be fair. I have to make it true. There's where I am. Now, because I have this kind of rule or pattern that I just found, I could say this equals x plus 5/4 squared. Okay. So I didn't change anything. I just wrote this. And if I multiplied this out, I would get this thing. Okay. This is yuck. Blech. What is this? 25/16. If this is times 4 plus 28/16. Now I have something terrible. 53/16 equals that. Okay, let's stay in call, please. All right. So where am I? Let's see. We got this yucky thing over here. We have x plus 5/4 squared. We can square root both sides. That's a rule. So I could say square root of 53/16 equals x plus 5/4. This is a plus or minus. Yuck. I'm going to just say minus 5/4, so I can write minus 5/4 plus or minus square root of 53 over 16 equals x. That's a terrible number. It's a negative, right over here, negative 5/4 plus or minus square root of 53 over 4, 16 equals x. So x equals negative 5 plus or minus square root of 53 over 4. Yuck, right? Like that was terrible. We can do it. It's possible. You could do this every time you had to solve for one of these, but why would we do that? If we could just do it one time and then like just kind of plug and chug or put it in a calculator or something like that. So let's erase this. We'll do it with A, B, and C. Okay. But I really want you to understand that the quadratic formula is nothing but a little bit of a time saver. All right, we don't want 4s and 10s and 7s. We want this. No, you can't see it. Ta-da! All right. The quadratic, let's just write the quadratic equation on the top to make it look very nice. The quadratic equation. All right, let's start the same way. We're going to subtract C. Actually, I'm going to put 0 over here first. Now I'm going to subtract C. That looks better. AX squared plus B, make this prettier, plus BX equals negative C. Oh, I really don't like this A in front of the X, so I'm just going to factor the A out. I can't really factor an A out, but I'm going to do this. I'm going to write B over AX. Because now A times AX squared is AX squared. AB over A is just B. So that's kind of like a little trick I have. Okay. Divide both sides by A. Well, I guess I could do that in blue so you can see what I'm doing. So I'm going to say divided by A, divided by A. Then I have x squared plus b over ax equals negative c over a. Cool. Now I want to add this piece, right? I want to add, what do I wish I had? So let's do that. X squared plus b over ax plus I wish I had a, we'll keep this over here, plus I wish, and then of course I'm going to have to add it here. So b over a is a number, and I need half of that. So that would be b over 2a. So I'm going to add b over 2a, but I have to square it because that's the second term there in the like this. Okay, so I'm going to add this kind of crazy thing, but I'm allowed to because I'm going to add it over here. Okay, I did it. So everything's legal so far. This now is the cool step where I completed the square. So now I can rewrite this as x plus b over 2a squared. So this term, if I multiply these two pieces out, will get me this. That's what I kind of just tried to show you before this. All right, so if you don't know why I did that, you better rewind. Ew, this looks yucky. So I'm going to try to get it all on a common denominator. Let's see. This one right here is b squared, and this is 2a times 2a, so it's 4a squared. And this is negative c over a. I know that I'm going to want them to be together, so I'm going to multiply the top and the bottom here. It looks like 4a times 4a, because now I'll have 4a squared, and I can add the numerators because I have the common denominator. Okay, let's put that here. So let's see. I have b squared. This is a negative. I'm going to put it in the back. Minus 4ac all over 4a squared equals this guy. Let's just rewrite him. Okay, no problem. Now we can do the fun part. Square root both sides. Let's do that. I'll do that in blue. Okay. Simplify. X plus b over 2a equals, don't forget you have a plus or minus when you square root something. You have two answers, plus or minus. Oh, and this is square root of something on the top over the bottom. So like, remember how you can say square root of 1/4 is the square root of 1 over square root of 4, which is 1 over 2. So I'm going to take the square root of the top and the square root of bottom separately because this one is ugly, right? B squared minus 4ac, but the bottom is a perfect square. You have the square root of 4 is 2, and the square root of a squared is a. So that's kind of nice. 2a. Woohoo! Something's happening. Then we're going to subtract that b over 2a to both sides. I know it. You saw it from the beginning. Oh no, we're running out of board. Eek. Oh no, we better move over here. So you can still see the old work and the new work. So we're going to come all the way up here. Ding, 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 ding. Okay, make sure you see what you're doing. Let's see. So we subtracted this, so we are just left with x, which is our goal, to be left with x, equals. Let's see. I'm going to write it in one step, and then we'll do the final. Negative b over b 2a plus or minus square root of b squared minus 4ac all over 2a. These are the same common denominator already. I don't even have to change anything. So just write it. Negative b plus or minus square root of b squared minus 4ac all over 2a. Did we do it? We did it. That's the quadratic formula, right? This is what people like to use a quadratic formula to solve for a variable. Yeah. So here's what's cool. So now when they give you some nasty thing and they say 3x squared plus 5x minus 7 equals 0, and they say solve for x, and you're like, oh, this looks terrible. It's okay. You just say this is your a, this is your b, this is your c. Now a would be 3, b would be 5, and c would be negative 7. Since we used a positive, this would have to actually be a plus and minus. That's fine. And then for your answer, you just say, well, that means x equals negative b plus or minus square root of b squared minus 4ac. So that's going to turn to positive, divided by 2 times a. Simplify that. 21 times, yuck. I think it's 8,409. I don't know what that is. It's about 10. So you have negative 5 plus 10 is 15 over 6. It's like something. And then negative 5 minus 10-ish over 6. Maybe negative, whatever that is. I don't know. I don't know what that is. That's a calculator problem. And you have a number. Most math teachers are fine with this. Just put 6 here. You're done. But it is 2 answers. So it is 2 answers. So that means it does like cross twice. Yeah, something like that. Okay, so that's nice. Sometimes you end up getting a really weird number in here, like a negative number. So if you got something like, if you ended up with like maybe x equals -1 plus or minus square root of -5 over 2, that's bad, right? So we call that not even a real number, and we call that an imaginary number, and that means your graph does not ever hit 0. So anyway, there you are with the quadratic formula derivation. You could practice that so you're good at it. I would say this is probably the hardest step right here, completing the square. Unless you don't like fractions, then you probably don't like getting the common denominator, but that's all it is. It's just a little thing. I can't memorize anything. So when I was in school, I just had to redrive it on every single test. But I got good at it. Bye-bye.